In this video, we'll go over a couple of important rules of dealing with exponents. But first, I just want to make sure we're all on the same page with a little bit of terminology. There are three parts to what we call a power. The first part is the number in front, that's the coefficient. And then the second part is the thing that's being raised to a power, that's what we call the base. In this class, if anything, that's typically going to be an x. And then the number up here is what we call the exponent. Please don't call that the power. We certainly can read this as -4 times x to the 7th power, but we still wouldn't call the 7 a power. The 7 is the exponent. The whole thing is the power. Just wanted to make sure we're on the same page with that so we can go over a few of the rules for dealing with exponents. The first rule is called the product rule, and I want to introduce this not as a statement, not as words, but as an equation, a statement of fact in math. And I'm going to avoid using x's here. Because I don't want you to think that this is only true for when we're dealing with x's. This is true for any base. M to the a times m to the b would be equal to m to the a plus b. We can certainly put that into words also and say that anytime you multiply two powers together, each one of these is a power, the base being raised to an exponent, as long as you're multiplying powers of the same base. They have to be the same. Then you can add the exponents. And this totally makes sense if you think about an example like x to the third times x squared. Well, thinking about what x to the third means and what x squared means, if you multiply it all together, of course, there's 3 x's in one pile and 2 x's in the other. So when you multiply them all together, that would be x to the fifth. A quick note about that rule is that I didn't put it in the rule itself, but if you have coefficients involved here, so 4x squared times 2x to the 8th, you multiply the coefficients together just like any other multiplication. 4 times 2 is still 8. It has nothing to do with the fact that we will be adding the 2 and the 8 from the exponents. X squared times x to the 8th is x to the 10th. The quotient rule is very similar, except instead of talking about the product, multiplying one power with the base of m times another power, like we did up here, we'll be talking about dividing one power with the base of m divided by another power with the base of m. And in this case, instead of adding the exponents together, we will subtract them. Like 12x to the 7th over 3x to the 3rd. We would subtract that. Well, first we can divide the 12 over 3, but we can subtract the x to the 7th. We're not subtracting x to the 7th minus x to the 3rd, but we do subtract the exponents, 7 minus 3, to get our new exponent. And this one also makes sense if we think about what division is. So I'll use a slightly smaller set of numbers here, like x to the 5th over x cubed. Well, if we think about what division means, we know that you can always cancel out x over x. So in this example, the x over x cancels, and what you're left with is the 2 at the end after we started with 5 in the numerator and we took out 3 of them, so we're left with 2. The next rule is a power to a power. Oh no, my pen just stopped working. Power to a power is m to the a to the b. In this case, we would multiply the two powers, two exponents, I should say, to get the final exponent. So m to the a to the b is equal to m to the a times b. And the last one I'm going to do is a product to a power. Let me do an example for that first one first. Like x to the third to the fifth, we would multiply them together as x to the 15th. Which makes sense. If you have x to the third to the fifth, that means x to the third multiplied 5 times in a row. xxx, 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 xxx. I think I got them all. That would be a total of x to the 15th. And the last one is a product to a power. That's when we have a full power including the coefficient. I'm just going to do this by example here. It's a little bit too complicated to do it by rule. So 2x to the third squared. The rule here is that the property that we're dealing with here tells us to distribute, actually I shouldn't say distribute, to apply the exponent to every factor in the product. So this would be 2 squared and x cubed squared. So we'd have to do them both, so that's 4x to the 6th. It's very important. I don't want you to call it the distributive property, but it's very similar to the distributive property, where we apply that 2 to both, that exponent of 2 to both. That's 2 and to the x cubed.